Hello again, everybody. It's been a while. So anyway, got some, I guess, feedback from people that still schematics are very confusing, and like I said, it's something that's very complicated at times. But first and foremost, I always start with the symbols. I took the opportunity to go and make a check mark next to the symbols that are very common all the time. These are symbols that you have to know in order to understand how to follow schematics. Of course, you have the positive, the negative, ground, fuse. As you can see, everything is self-explanatory. Resistors you have to know. Variable resistor, a series resistor. You'll find this in a blower motor resistor, where you actually change the speeds of the fan motor, high, low, medium. That's what this is. You have resistors in series. Other ones you always have to know relays. You have to know contacts, normally open, normally closed, and I made a check for everyone. That's obviously motors are very, very, very important. This means there's a connector, as you can see. Now this is obviously a heating element is in oxygen sensors. Now these are in alternators. This is something that maybe you haven't seen before. This is a digital readout. You'll see this on your clock. When you ever see it, it's like it's a digital display, and these are LEDs for each one. But anyway, when you see the symbol, you know it's referring to the clock mostly. So self-explanatory for both of these things. Now I tried to find the most simplified diagrams first, so people can analyze and understand schematics. So again, starting with the basics, and when the weather gets much better, we'll go out, and you'll see all the instruments, and more diagnostics under the hood, under the car. It's been really damp and rainy out here. Haven't had a chance. When it gets a little warmer, hopefully we'll go out and you'll see exactly what I'm talking about when I say how to analyze a relay. You'll see it visually under the hood. Let's start with this. You always start with the battery, the physical battery over here. Now, as you can see over here, there's always a switch involved or a fuse. Current flow. Remember, voltage is 2 points with reference to 1 point. A voltage is a force, a pressure. That pressure will eliminate, or actually it will extract a current to flow. It will force a current of electrons to flow through the circuit. There's obviously debates, positive to negative, negative to positive. That's not really important. What's important is that current does flow through this bulb, which is the load. So current flows here, follow the arrow, through this wiring, through one side of the switch, comes out the other side of the switch, goes in one side of the bulb, comes out the other side of the bulb, and it has to go back to where it came from, which is the battery. So regardless if you're going from minus to positive or positive to minus, the most important thing is for this bulb is as long as current is flowing. Doesn't matter the direction. Like AC, it does not matter. The most important thing is we need this to be closed to give us a complete path. We need this to be connected to negative. This negative goes sometimes to the engine block, which you will see. So if you have a problem sometimes, let's say the lights don't come on or the power locks don't come on, make sure that the negative is tight. You don't have corrosion and other things and rust around the battery terminals, like you'll see when we go outside. Now, if I want to measure voltage is between 2 points. If I put my meter over here, I'll measure 12. On a nice hot day, I'll measure maybe 12.3, 12.4. On a cold day, I'll measure less than that. So therefore, if I measure less than that on automotive battery, right? Remember, 12.2 to 12.4 volts of a battery, you're already at 50%, 75% of your charge. So 12.2 to 12.4, you're at 50% to 75% of your charge, believe it or not. So therefore, and there is a load tester to check the battery, which like I said, hopefully I'll show you hands-on what I'm talking about. Hopefully, March, it'll get a little warmer. If I want to measure the current flow, current, remember, is the flow of electrons. Where do I put an ammeter? An ammeter is a device, a measuring instrument to measure the flow of current. Where can I put this meter? I could put this meter over here. I could put this meter after the switch. I could put it before the bulb. I could put it after the bulb. I could put it over here to the negative. What's the basic idea? Wherever I put this meter to measure current, current will always be the same throughout the circuit. So for example, if I measure 2 amps over here, I'll measure 2 amps over here. If I measure 2 amps over here, I'll measure 2 amps after the switch. If I measure 2 amps before the light bulb, I'll measure 2 amps after the light bulb. I'll measure 2 amps coming back here. Wherever you go in the circuit, as long as it is complete. What do I mean by complete? It means that I have a path back to the negative. Current will flow. Remember, current flows. Power or voltage does not flow. What will I measure voltage-wise? Well, we always start from the load. I start from the load, or depends from the switch. I know I measure 12 volts here at the battery. I know I'm going to measure 12 volts before the switch. Why? Because this is just a regular wire. I do not lose any voltage through it. After the switch, how much should I measure? 12 volts here, 12 volts here. Why? There is no voltage drop across here, like a fuse. How much should I measure over here then? 12 volts. Again, why? This is just a wire. So 12 volts here. One side of this could be a brake light switch. What about the other side? Well, look at the other side where it goes to. It goes to ground. Therefore, it'll be 0 volts. So if I have 12 volts here, I have 0 volts across here. How much is the voltage drop across this brake light? 12 minus 0 is 12 volts. The whole 12 volts is across this. 0 volts across here. 0 volts across this wire. 0 volts across this wire. 0 volts across this wire. Now, let's look at it this way. Here we had one brake light. Guess what we're going to do? We're going to put 2 brake lights. Now, here's one light. Here's 2 lights. And how are they connected? They are connected in parallel. The reason being, and you'll see why. Let's start the same way like we did before. This is a voltage, a pressure, electromotive force they call it. To move, to pressurize, or to move the current to flow through these elements, these loads. But you'll see something different. That was a series circuit. This will be a parallel circuit. The concept is the same. It doesn't matter if I have motors, if I have light bulbs. Series and parallel is the same. Let's elaborate. How much should I have here? 12 volts. How much should I have here? 12 volts. Why? No voltage drop across here. If this would be a fuse, 12 volts here, 12 volts here. What do I need for this to light? This has to be in the closed position. That's why you have to know these symbols. This is a closed switch. If I go and I activate it and open it, boom, like that, instead of like this, current cannot flow. This will not be lit. This will not be lit. So if this will be a fuse and it will be blown, no current can flow through both reverse lights or brake lights. Current flows here, goes over here. Now this, we said was 12 volts here, 12 volts here. How much over here? 12 volts. Why? Because we did not lose any voltage drop through the wires or through the switch from the battery terminal. Now, 12 volts here, 12 volts here. How much should I measure at one side of this bulb? 12 volts. How much should I measure over here? 12 volts. This is a parallel. The same voltage here is the same voltage over here. Why? Because these are just wires. We did not lose any voltage through these wires. What about the other side? How much should this be? Well, if you trace it, it goes right back to the negative, meaning ground. 0 volts here and 0 volts here. Going back. As far as voltage is concerned, 12 volts across here, 12 volts across here. Why? Because 12 volts on this side and 0 volts on this side means I have a voltage drop. I lost the voltage. 12 volts across this. I lost 12 volts across this. Fine. Let's look at what's the difference between the current. The current we said before has one path. How many paths do we have for current to flow, to divide? We have 2 paths. So now the current over here and the current over here will split. The current is going out of the battery terminal, through the switch, the other side of the switch. When it comes to this point, it says, okay, I have two paths I can take. I'm going to take a path this way. I'm going to take a path this way. How much current depends on the resistance of both bulbs. If this has more resistance, less current will flow through this one, and vice versa. But the idea is, or the most important part is, current will flow, it will divide. Let's say if I have 4 amps. 4 amps. Resistance being equal of both bulbs. What will happen for the 4 amps? 4 amps goes out of the battery, into the switch, comes out the other side of the switch. 4 amps is still here. What will happen over here? It'll split. So since we know the resistance of this is the same, again, this could be brake lights, this could be reverse lights, which it is, and I'll show you the actual schematic. 2 amps here, 2 amps here. Is it important to me how much current is flowing? Not really. It's important to me that these are lit, that my reverse lights are lit simultaneously at the same time. When I put the gear shift in reverse, or if I step on the brake, both are illuminated. I know current is flowing through this one, current is flowing through this one. That current will divide here. It will join, come out here, come out here. 2 amps came in here, going over here. 2 amps came in here, going out here. Now, how much will be the current over here? 4 amps. The sum of the parts. If it divided, it has to be then summed together. So 4 amps here, back to the battery. So therefore, if these were reverse lights, both of them are not on. If this was a switch, I would say, okay, maybe the switch is open or the fuse is open. If one of them is working and the other one is not working, then I know I have, if one of them is working, I know I have 12 volts coming from the battery through the switch. And I know probably the bulb is not good. Let's take it a step further. The battery, and here is a switch here, 2 switches. Same thing applies. Current flows from here through the switch, through the bulb, back to the negative. But it needs 2 switches to be closed. If this is open, let's say this way, current cannot flow. If this is open, current cannot flow. It has to be, both of these have to be closed. If the open is here, in between the bulb and in between the switch, again, current cannot flow. When this is a good circuit and it's operating correctly, how much should I measure over here? Well, let's do it again. 12 volts here, 12 volts here, 12 volts here. Why? We did not lose any voltage drop through a switch. 12 volts here. How much on this side? 0 volts. Why? Because we connected back to ground. Now, the reason being why you have to be careful when you use ratchets or things like that, and you always take off the negative of the battery before the positive. Look what happened over here. And this is the best illustration I could come up with. Positive goes over here. Positive goes over here. And then two switches again. Same as the other one. But look what happened. I put a screwdriver, a metal screwdriver. So this positive now has current flowing through the metal of the screwdriver to ground. That's what they call the short circuit. Will the bulb be lit? No way. Why? Current always takes the path of least amount of resistance. So from here to here, there is very, very little resistance. 0 ohm or less than 1 ohm. Current says this is a good path for me. It will not light the bulb. That's what you call a short circuit, meaning from positive to negative, I was bypassed. That's why you always have to be careful. Metal, ratchets, and things like that. Let's go back to the actual circuit that we were dealing with. And this will summarize a lot of things. Now, again, starting from the battery, a fuse. Reese talked about there was a switch. Here's the switch we talked about. We threw in a switch, a fuse, right? Now you have two choices here. Manual transmission, automatic transmission. Again, this is a wire. This is a connector, like we said before. This is the color of the wire. This is located in the fuse panel. This is a turn signal flasher. You see this box over here? Meaning that this square box means there's one part of it and there's another part of it located in some other diagram. Doesn't matter. However, this is trying to get the reverse lights, the backup lights, to light. How many lights do we have? 1, 2. So therefore, remember, I always teach current, not power, not voltage. Current flows. Current will flow from the battery in the run position. Before you start the car, there is a run position. So therefore, two things have to be over here. First of all, current has to flow. One side of the fuse comes out the other side. What is the rating of the fuse? 15 amps. Goes through goes through this, activates the turn signal flasher, right? And to tell you that in the reverse lights, or the reverse lights are been activated. Now, current flows here through the connector. Again, two choices, manual transmission or automatic. We're going to go automatic. What do we have here? Again, a switch. This is normally open. You see this space? The gap means it's normally open. What do we have to do to close it? We close it like this. We activate it. We press it or we close it. This, you have to be transmission in reverse. Transmission has to be in reverse. Why? Because we're talking about reverse lights. Current flows through the connector, through this wire, through this switch, which is now in the closed position. As you can see over here, it's black, pink. As you can see, it's a striped one. See the stripe? Some schematics don't even tell you that it has two colors, but this one is a little fancier. It tells you two colors, as you can see by the wiring. Anyway, black and pink comes out here through this connector, C156, through another connector, C118, I believe, through another one, C350. The Ranger or a Bronco. If you're a Ranger, you are in automatic transmission you have. Now, this, we come to, again, a parallel circuit. And therefore, the current divides. It goes, some of it will split here, some of it will split here. And this will be illuminated when you're in the reverse position. So if you ever wondered how those lights are activated, through here. You close the switch. Through this, here, current can flow, and once they both flow, they come back to ground. So, out of just pure experience, let's say 15 amps, right? Let's say we'll have less than that, maybe 3 amps, 4 amps, whatever. Let's say we have 6 amps coming in here. We'll have 3 amps here, 3 amps here. Let's say we have 8 amps coming in here. We'll have 4 amps here, 4 amps here. Now, voltage-wise, when we troubleshoot, how much do we have here? 12 volts. Over here, 12 volts. Over here, 12 volts. Why? No voltage drop loss. Over here, 12 volts. Over here, 12 volts. Why? No voltage drop loss through the switch. How about this connector? How much do we have here? 12 volts. How much do we have here? 12 volts. Why? Just a simple wire. 12 volts here, 12 volts here. What about the other one? 0 volts. Why? Connected to ground. This is the same as this. That's why I introduced this one first, to show you switch is here, switch is here, the bulbs are here, the bulbs are here, the bulbs are here. If I measure 0 volts at this point, 0 volts, or both lights are not lit, what's the first reaction that I should have? I'll have 2 reactions. I'll say, of course, you'll say the fuse is blown. But if the fuse is not blown, what else can it be? Of course, I'll say the switch must be in the open position, or what else? This wire must be broken. Why do I pick on this wire? Why didn't I stress this wire? Well, if this wire is broken, I can still have current illuminating the other one. And if this is broken, this wire, this one, I can still have current illuminating this one. So therefore, if they are both out, how do I know? Well, I go and I put it in reverse, and I usually look at the reflection, the car in back of me, and I see a reflection of 2 lights. I know both are working. So therefore, if both are not illuminated, I come to the conclusion either the switch, either the fuse, or this wire, not these wires, or a ground could be open also. So therefore, A over here I put to signify this point. B I put over here to signify this point. Go over it. Now, a couple of tools that I wanted to stress. There's some tools that you can pick up, and they're very cheap for taking out the panel. Of course, the dashboard and all that. You don't want to use metal, because metal will scratch things. So it's better to use plastic. And these are very cheap tools that you get, especially this one. And there's another one that I took out. These are very cheap, less than $10 for sure. And you can use it to pry up the dashboard panel to get underneath it. And one more thing, I was asked about this one, the usual, the meter, which we'll do. I haven't seen this available on the internet. Like I said, I got it years ago from an auto parts store. I haven't really seen this manufacturer. CE it's called or something. So, but anyway, if you see something similar to it, again, this is for AC and DC. You don't really need AC. You're going to be using mostly DC amps to measure. That's that. The other one is for a scanner, the most cheapest scanner. The most cheapest scanner that you can find. If you just want to know codes and you want to know, I want to know operating temperature, closed loop, open loop. I want to know oxygen